Hi everybody, today we are going to be reviewing the difference of squares. So the difference of squares is another factoring tool that we can use, but we have some very specific requirements in order to do that. But first I want to talk about these examples that I have listed on the screen. I have two columns in my table. I have a list of examples of a difference of squares, and I have a list of non-examples. So the ones who are listed as examples are things that we can do as a difference of squares. The non-examples is a list of items that we cannot do as a difference of squares. So I want you to take a moment, think about how are they similar, how are they different, what do they have in common, what stands out as something different, and take a moment, think about that. Some of the common things that students have said is that in the examples column, there's a fraction where there is not a fraction in the non-examples column, and that is true. They all have exponents in some way, shape, or form involved. Also true. In the non-examples column, I see addition symbols. I see some expressions that have two subtraction symbols, whereas in the examples column, I only see singular subtraction happening in each of my expressions. What I also notice with some of these numbers, and this is true for both, some of these numbers like 36, 4, 16, 81, 25, 64, these numbers are all numbers that are what we call perfect squares. So they are squares of other numbers or a number multiplied by itself. So for example, 2 squared or 2 times 2 is 4. 4 squared or 4 times 4 is 16. 6 squared is 36. 5 squared is 25. These are all numbers that we're seeing on this table. So they all involve some sort of perfect square. So let's get to our difference of squares. So this is a little checklist of requirements in order to make a binomial factored into a difference of squares. And there are a few things that have to be checked off or confirmed in order for a question to be a difference of squares. One, that it has a minus sign between the two terms. That is very important. Must have a minus sign between the two terms. The second is that the constants or whole numbers are perfect squares. So any number that we see is a perfect square. And then the last one is that the exponents are even. So that means they are like x squared or y to the power of 4 or z to the power of 8. They're all going to be even numbers. And an important factor to note is that you might have to factor out the GCF to make the rules apply. That's just true. You might have to factor out that GCF to make the rules apply or be true. So for example, I might have 3x to the power of 3 minus 12x. Well, I can factor that. I can take a 3 out of both terms, and I can take an x out of both terms. So then that would leave me with x squared minus 4. So now on the inside of the parentheses, I have even numbered exponents, I have subtraction, and I have a number that is a perfect square. The 4 is a perfect square. So we might have to factor it first by GCF before we can actually break it into the difference of squares factor. Now here I have a table of perfect squares for you to reference of numbers 1 through 10. You may see numbers higher than that, but you can always use your calculator to figure out if it's a perfect square by using the square root symbol. So for example, if I take 25 and I put a square root over it in the calculator, I should get 5 as my answer, which is right here. So if you aren't sure about a number, you can always take the square root of it in the calculator in order to find out if it's a perfect square. All right, getting down to the actual business of factoring these. When we factor a difference of squares, our answer, what we are looking for, is going to have one addition symbol and one subtraction symbol. So it's going to be two sets of parentheses, two binomials, one with addition, one with subtraction, but with everything else the same. So whatever letters or numbers are going to be the same. So keeping that in mind, my first example here says x squared minus y squared. So I want to think about, what does x squared represent in terms of perfect squares or in terms of multiplication? Well, x squared is x times x. Y squared is y times y. So now I have two x's and two y's. I'm going to take my two binomials, one with addition, one with subtraction. Each is going to get an x, and each is going to get a y. And that is factoring a difference of squares. That's our answer right here. That's all we are going to do. So we're going to do that again. Our next example has numbers in it as well, so we have to keep in mind, can we factor out a number? So I've got 16x squared. 16 is 4 times 4. And x squared is x times x. So we have 4x and 4x. 49 is 7 times 7. So again, we're going to set up two binomials, one with addition, one with subtraction. 4x is going to go to the front of each, and 7 will go at the end. And that is our final answer for that example.